Welcome to This is Go Magic, where learning things together is magical. We talked so far about precision, accuracy, systematic uncertainty, random uncertainty, describe it, understand it, and now the best way to understand those new terms is actually to do a question. Okay? So question 18. You have a graph of d against t squared, second squared, d in centimeters, which is not passing through the origin. It's about a story of a plank where you have a car and then you let it roll down, where they have a fixed measurement of where the d is, which is this d in particular. So let's check the first sentence. Is there anything important that we can extract out? Remember, error question, make sure you extract all the information before doing it, because that will help you when it comes to solving the question. First line, the only thing to extract is they're trying to determine the linear acceleration. So let's check whether there is a question you're going to ask soon. Then the next line, nothing to extract because they already mentioned, they just something on the parameters is shown. Then the third line, they're just talking about the graph. The time t to move from rest through a distance d is found for different values of d. Careful, the key word here is from rest. You see in the previous episodes, or rather uncertainties and systematic uncertainties, from rest means this. Before this object starts to move at t equal to 0, its distance move or displacement move must be equal to 0. So please look for the keyword from rest. You already see from this graph. As long as you extract the information correctly, without even knowing the question, you already know which direction you are actually going to. Fourth line, nothing important. It mentions about a graph, d against t squared, which is quite odd. Notice, usually it's distance against time. But what is that, t squared? Okay. Extract information. That's all the information we are able to extract in this case. So let's go to part A. Name the feature on the graph that indicates the presence of random error. So they want evidence from graph to show random error. As you can see from the graph, if it's in front of you, you notice one of the key components of random uncertainty when it exists, where regions are scattered equally about the line of best fit. So what is the evidence? Similar to the graphical definition that was mentioned in the previous episode. So your answer will be readings scattered equally about line of best fit. Second question, as the more questions you do, you realize it's quite connected. They want evidence for systematic error. What is its evidence? Remember again, questions, you must extract information you need as well. That will help you to solve the question. Sometimes the questions might be long and tedious, so you must be able to extract the terms that you need so that you can solve it rather quickly. Systematic error, if you extracted your information earlier from the question, you already know this object should be starting at 0. But it's starting when time equals 0, it's already a distance d apart. That means, what's the evidence? Go back to the graphical definition. line does not start from origin. So, notice easy marks. As long as you understand the graphical formats when systematic uncertainty is present, when random uncertainty is present, they can easily answer these sort of questions. The next one, B, determine the gradient of the line of the graph. So next one is gradient. So please take a paper and find your gradient. Remember as well, I mentioned a lot of times to you guys, please, when it comes to gradient, don't just put numbers in. Now you're at A level, please put the units in so that it will make the life easier when you need to find the units of the gradients. So you have cm, which is the y component, and second squared, which is your x component. And the answer will be around, since this graph, there will be a range for this answer. So your range here will be around 10.4 all the way to 10.8 centimeter per second square. So as long as you get this value, you should be okay. Another problem that most students face: do you get the best value or not? So if I were you, I will pause a bit a moment and then find the value of your gradient. Then, after that, unpause the video and then I will show you the points I've taken and check whether the points are the same as yours. Try to see the difference between the points you have chosen compared to mine. Understand why the points I've chosen are better points. So, over here, let me choose a good point for you. And that will be at 10.6. So, t squared, we go to 10.6 second squared, and d is equal to 106 centimeters. So the first coordinate will be 10.6. Apologies, the x value is correct, 10.6, followed by 106. The next point, let me choose a good point for you so that you can have. So now, these are coordinates. Please double check and see whether it fits to your coordinates well as well. If not, then check why I chose these points as the best points compared to the points that you have chosen. Next part, your value will be around this range. C. Use the answer to B to calculate the acceleration of the toy down the slope. Explain your working. Now they want you to find acceleration using the gradient. We have a problem. How do we actually get acceleration from the gradient? When we do a velocity time graph, you will recall that the gradient of a velocity time graph will give you acceleration. But problem, this is not a velocity time graph. This is a distance graph against time squared. So how do we do it? Remember the 5 phases of motion. Let's go through the 5 equation motions again. The first one is S is equal to U plus V over 2 times time, also known as average velocity times time. You got definition of acceleration, V minus U over time, also known as delta V over delta T. You have S is equal to UT plus half AT squared. You got S equal to VT minus half AT squared. And you got V squared equal to U squared plus 2S. So I hope you guys remember that. Sometimes questions will require you to remember the 5 equation motion because this graph, if you actually think about it, is actually related to one of the equations here. Let's change distance to a variable that you recognize. In this case, as per centimeter. T squared. You can already notice there's only 2 equations. That's S against T squared. Let's say you chose the first one. S is equal to UT plus half AT squared. According to the first information, it begins at rest. That means your initial velocity is actually equal to 0. So you got S equal to half AT squared. But wait a minute. What line is this? This is a straight line graph. Y is equal to mx plus c. Therefore, if you put y is equal to mx plus c, you notice that your y is your s and your t squared is actually your x. So what is your gradient? Your gradient here is equal to RA. Therefore, acceleration is equal to 2 times gradient. Just make A the subject. And gradient is here. Put in the value in. Let's say your gradient is 10.6 centimeter per second squared. Therefore, your acceleration here would be 21.2 centimeter per second squared. Okay, so it's important to remember the equations they use for each topic, but only then you'll be able to check for questions resembling these sort of questions, where sometimes the graph is not something you learned before, but it's actually still doable as long as you remember the equations you use and just apply it, and then you'll be fine. So I hope you understand this question, how we did it. If not, please replay this